Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discuss a problem on bisection method. In previous lecture, we discussed the general procedure. So now we are going to see the problem based on the bisection method. So now you can see here, okay. So solutions of equations in one variable. This is the topic name. Solutions of equations in one variable. One variable is nothing but if you take equation in x in terms of x, the total equation in terms of x only. If you take y, the total equation in terms of y only. X, y, z, whatever it may be, you have to take in only one variable only. So we have two variables also, and we have higher orders also. Okay. So the bisection method. First method is bisection method. Find a root correct to three decimal places lying between 0 and 0.5, okay, of the given equation. For e power minus x into sin x minus 1 is equal to 0. Okay, so that is the given equation. So the given equation is not an algebraic equation, so this is the transcendental equation. Okay, so transcendental equation. What is a transcendental equation? The equation which consists trigonometric, exponential, logarithmics all mixed. Okay, so that the type of equations is called transcendental equations. So for example, if you have equation in this format, x square minus 2x plus 3, it is called algebraic, only algebra terms, x square x cube. If you have these terms, you can call it as an algebraic equation. If you have sin x, exponential, log x ఈ format లో ఉంటే, so you can call it as a transcendental equation. Now this is our required equation, f of x is equal to 0, and we have to find out the root in between. In the problem only they clearly mentioned that 0 and 0.5. okay, in clearly mentioned that 0 and 0.5, so that means you have to take it as a and b, and the required solution we have to represent in the three decimal places. That means after decimal point you have to put three significant digits. Okay, up to three significant digits you have to take the solution. So now you can see the solution. Given equation is, okay, so given equation is 4ex 4 into e power minus x into sin x minus 1 is equal to 0. Let, okay, first of all the given equation, let we are taking that. So f of x is equal to 4 into e power minus x sin x minus 1. Okay, so that is taken as equation number 1. Here our aim is, so you have to substitute 0. First you have to substitute 0 and 0.5. So for f of 0 in place of x, so you will get minus 1. 4 into e power minus 0 into sin 0 minus 1. If you simplify that value, you will get minus 1. Minus 1 is the real number, negative real number. Okay, you will get less than 0. Okay, f of 0 less than 0. So therefore f of 0 less than 0. Next value is f of 0.5. f of 0.5 is equal to, substitute in place of x. So 4 into e power minus 0.5 into sine 0.5 minus 1. Okay, so if you simplify with the scientific calculator these values, so you will get 0.163. 0.163, it is a positive number. 0.163 is the positive number, so therefore you will get that greater than 0. So therefore f of 0.5 is greater than 0. In the statement of the problem only they clearly mentioned that 0 and 0.5. So then you have to consider as a is equal to 0 and b is equal to 0.5, and you have to substitute those two values only. If they did not give those values, by trial and error method you have to substitute 0, 1, 2, 3, minus 1, minus 2, minus 3, okay, respective values to get the opposite signs. Here f of 0 less than 0, okay, here f of 0 we got less than 0. Here f of 0.5 greater than 0. So two values we get consequently. So therefore f of 0 less than 0 and f of 0.5 greater than 0 both have opposite signs. Opposite signs means plus minus. So therefore then the required root of the equation 1 lies between 0 and 0.5. Okay, so for this 0 and 0.5, the required root, what we are going to find out, the required root lies between 0.5. That means now I will draw a real line here. Okay, so 0 is here and 1 is here, 0.5 is here. Okay, so 0.5 is here. So now our required root lies between here only, these 2 points only. Okay, in between this 0 and 0.5, either it might be 0.345, 0.467, 0.543, in this format, whatever it may be, the required root exists in this format only, 0 and 0.5. So here a is equal to 0 and b is equal to 0.5. So okay, so now I am starting the iterations or approximations. Initial approximation from the bisection method, the initial approximation for after getting a and b values, our aim is x naught is equal to, okay, so x naught is equal to a plus b by 2. You have to take the average value, mean value for those two a and b values, a plus b by 2. So that gives the initial approximation, x naught is equal to, you will get 0.25. X naught is equal to 0.5. So is 0.25 exist in between 0 and 0.5. Okay, if you write here 0, okay, and if you write 0.5, 0.25 is the exact middle value. Okay, so therefore now if f of x naught is equal to 0 in equation 1, then x naught is the root of f of x is equal to 0. In general procedure we discussed at the same point, that is only I am writing here. If this f of x naught, that means 0.25 is, if you substitute in equation number 1, if you get the equal to 0, that is the root. So therefore if f of x naught is positive, and that means if you substitute that 0.25 in equation 1, if you get the positive number, it is become greater than 0, then the root lies between a and x naught. What is the a? 0, x naught 0.25. okay, otherwise if f of x naught is negative, okay, that means f of x naught less than 0, then the root lies between x naught and b. You have to write these three statements in the proof. Okay, so then only they will understand clearly. So therefore we have, now we are substituting f of x naught is equal to f of 0.25. okay, so substitute in the given equation and calculate with scientific calculator, you will get minus 0.229, minus 0.229. Here minus symbol is there, so you can write it is a less than 0. Less than 0 means you can apply this condition. If it is negative, okay, so you can apply this condition, f of x naught is negative. So if f of x naught is negative, then the root lies between x naught and b. X naught and b means, so therefore f of x naught is negative, it follows that the root lies in between x naught and b. What is the x naught value? 0.25. So therefore this is the x naught. You can clearly see here, this one is the x naught and this one is the b and this one is the a. Now the required root lies in between these two values. Okay, so for this first approximation, x naught and b, okay, from here to here, in between these three values 0.25 to 0.5, the required root exists. Okay, so therefore now x naught as you have to consider as a, x naught you have to consider as a, and b is equal to 0.5 itself b only. Now first approximation you can take x1. okay, so therefore x1 is equal to a plus b by 2. What is the a value here? That means x naught 0.25 plus 0.5 by 2. You will get x1 is equal to 0.375. x1 is equal to 0.375. Again, after getting that x1 is equal to 0.375, okay, substitute that value in the given equation number 1, you will get 0.007. That is greater than 0. F of x1 value we got greater than 0, it is positive. If f of x1 value is positive, okay, so positive is nothing but you have to see the previous step, which value is less than 0. So therefore f of 0.375 is positive, therefore the root lies in between 0.25 and 0.37. Why? Because 0.25 in the previous step, 0.25 is the less than 0. Here we got greater than 0. These two values are the, okay, this value and this value, these two values are the consecutive values. consecutive opposite signs, less than 0, greater than 0. Now for this, okay, for f of 0.25 and 0.375, the required value exists in between them. So now you can draw a real line here. Okay, so 0 is here and 0.5 is here, and in between 0.25 is here and 0.35 is here, 0.375 for example, for your understanding. So now the required root light in between them. Okay, so therefore 0.25 and those two values only exist in between 0 and 0.5 only. Okay, so this one is A, this one is B, they will not change. This one is x0. Now we got x1. Next to in the second approximation, you can take the mean value. For these two values you have to take the average value. So therefore that is taken as second approximation. Second approximation is equal to x2. X2 is equal to this one x0 plus this one x1. So therefore x0 plus x1 by 2. Okay, so therefore you will get this value 0.3125. So okay, x2 is equal to, you will get 0.313. Here we got 4 digits now. So you have to correct the 3 decimal places. In the statement only they clearly mentioned that 3 decimal places. So 312. This 2 you have to convert into 3 decimals. That means here 5 is there. 5 is half of the greater than unity. So therefore then you have to add plus 1 for the previous number. Previous number is 2. For 2, if you add plus 1, it will become 3. Okay. So here we have 0.3125 is there. Okay, first to 2 decimal no problem. 0.31 is the fixed for first to 2 decimals. Here third decimal is 2 and fourth decimal is 5. Now with the help of these two elements you have to write down the third element, that is 3. Why? Because here 5 is the half of the greater than unity. So therefore you have to add plus 1. Okay, plus 1 to third element. So therefore it will become 0.313. Okay, so that is the x2 value. Now substitute x2 value in f of x. Okay, that is equation number 1. You will get less than 0. F of x2 less than 0, that is minus 0.0099 less than 0. So now you got less than 0, it is negative. So you have to see the which number we got positive. Okay, that is greater than 0. So therefore the root lies in between for 0.375 and 0.313. Okay, in previously for 0.375, okay, that is the x1 is the positive. Okay, now we got x2 is the negative. So therefore for these two values you have to take the average value. So that root lies in between them. Now in third approximation you have to take the mean of these two numbers, x3. For this one is the x1 value, this one is the x2 value, x1 plus x2 by 2. So that gives that x3 value. So therefore substitute that value, f of x3 is equal to f of 0.344. So therefore you will get again less than 0. Less than 0 means negative. So negative. Consecutively you get negative. Previous step in the second approximation we got negative. Okay, in the second approximation we got negative. In the third approximation we got negative. Negative is consecutively we got less than 0. So now you have to consider this negative and previous step which we have positive. Okay, previous step what is the positive? So that is the first approximation we got positive. So this positive you have to consider. So now you have to find out the you have to take the mean for this positive. Okay, and here you have this negative. Okay, so therefore the root lies in between 0.375. The root lies in between 0.375 and 0.344. 344 is the x3 value. So therefore that is taken as the third approximation. So you can also draw a real line. For each and every approximation you have to draw a real line now. Okay, so therefore here 0.375 and here you have 0.344. If you continue this one, 0.5 is there. If you continue this one, 0 is there. That is the format. Okay, so now the fourth approximation you have to take the mean for these two values. So you will get 0.360. Substitute that value in the given function equation number 1. Again here you will get less than 0. Again you are getting negative only. Therefore is again negative. So therefore the root lies in between. ఇక్కడ నెగిటివ్ వచ్చిందంటే ఇంతకు ముందు మనకి ఎక్కడ పాజిటివ్ వచ్చిందో ఆ వాల్యూని తీసుకోవాలి. ఆ పాజిటివ్ వాల్యూని ఈ నెగిటివ్ వాల్యూని. ఇంకా ఈ రెండింటిని మనం కన్సిడర్ చేయం. ఏది థర్డ్ అప్రాక్సిమేషన్ లో వచ్చిన నెగిటివ్ ని, సెకండ్ అప్రాక్సిమేషన్ లో వచ్చిన నెగిటివ్ ని మనం కన్సిడర్ చేయం. ఫస్ట్ అప్రాక్సిమేషన్ లో వచ్చింది కదా పాజిటివ్, ఆ పాజిటివ్ ని ఫోర్త్ అప్రాక్సిమేషన్ లో వచ్చిన నెగిటివ్ తోటి మ్యాచ్ చేస్తాం. సో దేర్ఫోర్ ఇదేంటి మనకు ఫస్ట్ అప్రాక్సిమేషన్ 0.375 అనేది ఫస్ట్ అప్రాక్సిమేషన్ లో వచ్చినది. సో ఇప్పుడు 0.360 ఫోర్త్ అప్రాక్సిమేషన్ లో. ఓకే, సో ఆ రెండింటిని తీసుకొని మనం ఫిఫ్త్ అప్రాక్సిమేషన్ కి యావరేజ్ ఫైండ్ అవుట్ చేస్తాం. సో దేర్ఫోర్ 0.3672. సో దెన్ 3 డిజిట్స్ కి 0.368 రాస్తాం. సో దాన్ని మీరు సబ్స్టిట్యూట్ చేసుకుంటే అగైన్ ఇక్కడ మీకు మళ్ళీ నెగిటివ్ 0, లెస్ దెన్ 0 వచ్చింది. ఫోర్త్ అప్రాక్సిమేషన్ కూడా లెస్ దెన్ 0, ఫోర్త్ కూడా లెస్ దెన్ 0. చూడండి, if you observe carefully, second approximation negative, third approximation negative, fourth approximation negative, consecutively we are getting the negative values. Okay, so we are not taking these values. Okay, so we are taking the first approximation value positive and negative. So therefore here also we are getting negative. So therefore in place of a value, so the root lies in between 0.375, okay, as A and 0.368 as B. So therefore again if you take the average for those two values, it will give the sixth approximation. Okay, in sixth approximation x6 is equal to 0.372. Okay, so if you substitute in the equation number 1, you will get greater than 0. Greater than 0 means it is positive. Now you got positive. Okay, if you get the positive, now you have to search for the negative. Okay, where is the negative? In the fifth approximation. Okay, so sorry, the fourth approximation. In fourth approximation we got negative. Negative and positive came consequently. Okay, so therefore you can make a relation, that is seventh approximation, that is the average of these two values. So therefore you can write this one, 0.368 is the fifth approximation and 0.372 is the sixth approximation. If you make the average value, then you will get that seventh approximation, 0.3692. Okay, so you can take it as a 370 if you correct to the 3 decimal. Again substitute x7 in equation number 1. Again here you will get less than 0, negative. Okay, so here you can see that negative. Here you have positive, here you have negative consequently. So you can, for both these two values, okay, you have to apply the relation. So therefore this is x7 value and this is x6 values. So therefore x8 is equal to average of x7 plus x6 by 2. So therefore if you proceed in this format, again here we will get positive. In the 8th approximation greater than 0, so therefore it is positive. So it positive means in previous only we got negative. Okay, in the 7th approximation we got negative and in 8th approximation we got positive. So consequently is there. So therefore you can take the next 9th approximation for them. Okay, so this one is the x7 and this one is the x8. So therefore x9 you will get 0.371. So therefore we got x suffix 8 as a after getting that 9th approximation, you have to observe that in 8th approximation we got x suffix 8 is equal to 0.371. Okay, in the 9th approximation also we got x suffix 9 is equal to 0.371. Both approximation roots are same. Okay, so x suffix 8 we got 0.371 and x suffix 9 we got 0.379. Okay, if you proceed furtherly, x suffix 10 also you will get 0.371. Why? Because the same value you are substituting, you will get the same roots only. Okay, so therefore if you proceed in this format, you will get the same root. So therefore you have to terminate the approximation process at the 9th approximation. Okay, after getting the two consecutive approximation roots, two consecutive same approximation roots, you have to stop the process. Okay, so therefore and we proceed in this format, we will get x10 is equal to 0.371, x11, x12 up to so on by successive approximations. So therefore x is equal to 0.371 is the root of the given equation 4 into e power minus x into sin x minus 1 is equal to 0. Given for the given transcendental equation, root is x is equal to 0.371. So okay, now 0.371 is the correct to 3 decimal places. అంటే మనం బిగినింగ్ ఆఫ్ ద ప్రాబ్లం నుంచి ఆ x1 x2 x3 వాల్యూస్ ని ఒరిజినల్ గా క్యాలిక్యులేట్ చేసినప్పుడు 4 డిజిట్స్ వస్తున్నాయి డెసిమల్ తర్వాత, బట్ దాన్ని మనం 3 డిజిట్స్ కి కన్వర్ట్ చేస్తూ తీసుకుంటున్నాం. ఓకే, సో బిగినింగ్ ఆఫ్ ద ప్రాబ్లం నుంచి చేస్తున్నాం కాబట్టి నో ప్రాబ్లం. సో దేర్ ఫోర్ సో 0.371 ఈస్ ద ఒరిజినల్ రూట్. ఈ 0.371 అనేది ఒకసారి మీరు రియల్ లైన్ డ్రా చేసుకున్నారు అనుకోండి, 0. Okay, so 0.25, this one is the x naught, and 0.5 is the b, a b. Okay, now our required condition is 0.71. That means it is exist in this format here, 0.371. this is x8 x9 అన్ని ఇక్కడ నుంచి మీకు స్టార్ట్ అవుతాయి అన్నమాట. సో దీనికన్నా ముందు మీకు ఎంత వచ్చింది, x1. సో x1 మీకు 0. సంథింగ్ వచ్చింది 0.3 లో, x2 కూడా 0.3 లో. సో వీటన్నిటికి మీరు ఒక గ్రాఫ్ డ్రా చేశారు అనుకోండి. ఓకే, సో ఇట్ విల్ గివ్స్ దట్ ద బైసెక్షన్ మెథడ్ డయాగ్రమాటిక్ రిప్రజెంటేషన్. ఓకే, సో దిస్ ఇస్ ద టోటల్ ఎక్స్ప్లెనేషన్. చూడండి, రిక్వైర్డ్ రూట్ అనేది మనకు ఈ రెండింటి మధ్యలో ఎగ్జిస్ట్ అయింది, 0.25 to 0.5, దట్ ఈస్ 0.371. సో 0.371 is the exact root for the given transcendental equation by using the bisection method. So ఇక్కడ మనకి ఈ రూట్ రావడానికి we have gone through all 9 approximations. Okay, it takes lot of time. That's why we are calling rate of convergence of the bisection method is very slow. It will take lot of time. So the next slide we have the table. For each and every problem you have to write the table in this format. Table approximation roots for the given transcendental equation, successive approximation, 0 approximation, first approximation 3.375. okay, for them if you draw a real line, clearly you can know that 0 and 0.25. okay, next 0.375. so next 0.313. 313 means in between 0.375 only. For your understanding purpose I am writing in this format. Okay, so if you observe carefully, the required root exists to 0.25 to 0.5. so therefore final root is 0.371. so if you make a table in this format at the end of the problem, okay, so definitely you will get the full marks. Okay, so this is the total explanation of the problem by using the bisection method. The same problem we can also find the solution by using the next upcoming methods, that is iteration method, Newton-Raphson method, Regla-Falsi method, Muller's method. Okay, the same problem, same transcendental equation solution we can also find by using the upcoming methods also. But for the bisection method, this is the process. So this is the total explanation of the entire problem. Okay, I hope you understood this problem very well. In the next lecture we are coming with another interesting topic. Okay, so make a perfect practice, prepare well. Until bye, thank you.